Okay. So the first change that's going to happen, but your pivot lab. Okay, so remember I published the module. I told you I could work ahead if you wanted. The pivot lab that used to be a grade is no longer going to be taken as a grade. So the pivot lab is now optional if you want to versus a mandatory grade. We're just getting rid of it because we haven't seen you guys in a week. There's been a lot that's happened in that week. And we want to make sure you have the time to prepare for your test Thursday that you need to prepare. Okay. Instead of the pivot lab, you will have the practice test as a grade, which has unlimited attempts and will directly help you on the test. Today, we're going to go over what a titration is quickly by using one of the videos from a pivot lab. And then we're going to go over the math of titrations today together, which will also review stoichiometry for your test Thursday. I had a quizzes that I made to help review advanced or pre-AP chemistry acid base for my IB kids before they started their unit. So I will post that if you want, but the practice test is the best way to review. And so you'll have the practice test. All QCs I'll accept through Thursday. So like Thursday before the test, that's when I'm making the due date. I'm extending it out so you have time to deal with things, okay? So if you need to have an extra minute or whatever, to catch up because a lot of classes are behind, and I know a lot of teachers are feeling we have to do this and whatever, so I don't want to put more pressure on you, stress on stress. I also am going to ask you guys for 5 minutes to let me talk to you guys about non-chemistry things. Okay. So what I really wanted to make sure I sat down and talk, like, how have your teachers been actually, like, and this is not throwing anyone under the bus or whatever, I'm just kind of curious, how have your teachers been handling yesterday and today since you got back? Are they like giving you more time? Are they reviewing? Are they pretending nothing ever happened? Like, what is your guys' experience now that you're back in school?
Half of my teachers are trying to like press all of the work from last week into this week, combining it with this week. And so we're just like overloaded with work in those classes. And the other half of my teachers are just like, okay, we're just going to move all of our grades into the next quarter so they're not due. So my workload kind of evens out because half the teachers are like, you don't really have to do much work. And the other half are like, you have so much work.
Yeah, is that what everyone's experiencing? You guys feel free to speak up. This is an open conversation.
My
Yeah.
teachers are well, I know that my math teacher, she's like eliminated some quizzes and stuff, and then I think some other teachers are just like rescheduling their whole calendar so we can still do like the assignments we were supposed to do last week. But yeah, and then one other teacher is actually just giving today. She just gave like a whole class period to like catch up.
Yeah, I'm reading the comments too, guys. Yeah, I know, like, I've been hearing mixed things from other teachers. So, like, for me, what I advocated for you guys, I'm the one that advocated for the lab to be removed. Like, just take it out. If you want to do it, you can, etc. Um, because I figured that was kind of happening. I know in my IB class, I'm redoing my calendar back end. Luckily, both in this class and my IB classes, we had extra days scheduled in the other units just in case. So we're just kind of like those extra days or catch up days are just gone now. So we kind of are just shifting. Um, yeah, A-Day actually had it the worst for us because I mean, you guys have felt it. Like there was the weird snow day and then they're gone for a week. I hadn't seen them since last Tuesday. And the other thing that's going to happen, and this is what I really want to talk to you guys about. So you guys all know I'm a big proponent of mental health and all of those things. I hope you know that, but from the way that I teach and the way that I approach you guys, that mental health is a very big deal to me for a lot of reasons. One of them is because I was raised in the generation where like if I complained, I was told to suck it up, and if I still complained, I got smacked. Like that's how our parents were, and I don't want you to think like that's okay or normal because it's not. And I love my parents very much. It was a very different generation. Like my parents are boomers born in the 40s and 50s, so like they old. But that actually kind of messed me up for a while, that I wasn't allowed to have emotions. I was just, oh, you're a hormonal teenager, just suck it up. Or like if I got upset, they would just try to distract me with something versus just like letting me have my feels. And so I don't know if you guys have ever seen this. And like I said, this is not chemistry related at all. This just, adults do this weird thing where you guys look like mini adults. Like you walk and talk like us, but like you are still learning how to be an adult. You're adults in training. You're not there yet. Your frontal lobe is not there yet. A lot of you are very mature and wonderful, but you literally don't have the same frontal lobe development that we do to help process emotions. So our emotions get bigger and we're more impulsive as teenagers. It's just, I mean, I was a wreck. Like it was fine. I thought I had it together, but I was a wreck. Let's be clear. Like I was like, I have a 4.0, nothing could be wrong. And everything was wrong. Like I just used the grade to shield myself and pretend like nothing was wrong. So like adults forget to talk to you guys about emotions and how to deal with them and what trauma is. So I personally make it my mission to talk to you guys about it, because you need to have an adult at some point in your life tell you that emotions are normal and okay. So I was going to show you this. So last week, a lot of people experienced a very ranging experience. There's a very wide range of experiences last week. Yes. So like, you don't have to share if you don't want to, but like who lost power? Like I didn't have power for a while. Did anyone else like lose power, cycling power? Like what was your experience?
We had the rolling blackout thing, so it was like on and off, like 30
Yeah.
minutes on, an hour off.
Yeah. Mine wasn't on like a perfect schedule. It was like we got 20 minutes sometimes and then it would go away for an hour and then be on for 30 minutes and then it was gone for like 2 hours and be on for 20 minutes. And it was enough to keep our house at like 50 degrees so our pipes didn't burst. But like every time it went off, we got a text alert from like Citywide saying, don't expect it to come back on. It's probably gone forever. So that was like super stressful, right? I'd like batch cooked. Luckily, I'm from the north, so I had winter clothes. And like being from Michigan helped. And I also already knew to like cover the windows and things. So we did all that. And I live on the lake. So we like literally went out to the woods and drug back dead branches and chopped them with axes. Like we were Laura Ingalls Wilder or whatever. And like, and that's how we kept our house warm, was this fireplace. Right. So that actually needs to be repaired. So that was also a level of stress. Like, well, do we have a fireplace with a crack on, or do we not have heat? We're gonna risk it. We're gonna go for the heat option. But yeah, and then people's pipes were bursting. I have friends on boil order. Yeah, I see a lot of you guys lost all food. It's been a long time. So I don't know if you guys have seen this. Have you guys seen Maslow's hierarchy of needs? Have you seen that? Okay. If you have not seen that, this is the basis of how you human. Okay. It's a theory from a guy. And if you take AP Psych or whatever, it's a really cool section. I love this part of psychology. My minor was in behavioral psych, so we talked a lot about this. But there are certain things humans need to function. And if you don't have your base needs, your higher functioning doesn't exist. We are very, very fortunate in Allen and the surrounding areas of Texas that for most of us, this was probably the first time we actually felt scared for our safety in our domicile, right? Like home has always been a thing, but like you guys are experiencing for the first time what a lot of people experience all the time elsewhere. We are very fortunate that we were born here, but that basic physiological need, I have students that have told me that they slept in warming shelters for a couple days because their pipes burst and their heat was out and their floor literally turned into an ice rink because it flooded and then the power went out and it froze over. Like people had varying experiences last week. So if you were worried about your water, if you weren't sure if you were going to be able to cook your food, a lot of you lost all your food because it went rotten in the fridge because it wasn't refrigerating. You probably weren't sleeping well because it's cold. All of those things, the rest of your functioning above this doesn't really happen. Like people are like, oh, it's been a whole week, I forgot everything. It's not just that it's been a whole week. It's that it was a week where the base of your pyramid was devastated. And even if your power was fine, like I've also had students say things like, well, my power was completely fine, but you know, my friend's power went out or my mom's pipes burst or whatever it is. So there's a basal level of like basal being base level of like concern that you had last week. Would everyone agree? Like there were concerns, like you weren't sure and you're seeing the news, like reading the news about kids freezing to death in their beds and things like that. Like that's scary. and it was real, and it was statewide, and it was millions of people, and that is terrifying, right? It's just like, it is. And even if you're like super cool and play it cool, you're gonna have some response to that emotionally, period. Whether it's just like, oh my God, I'm glad it's not me, or it's, oh my God, that could have been me, or oh my God, that was me, or whatever it is. You have these varying range of emotions, okay? So if these aren't here, the rest of them don't happen. So this week, you guys may experience things like memory loss, lack of memory attention. Usually when I ask you questions, you're like, okay, I can figure this out, but your brain just isn't giving you an answer because there are literal hormones built up in your body from stress. When you experience extreme stress, you had fight or flight every time the power went off or whatever was happening, adrenaline, cortisol, all those chemicals build up, and it takes a lot longer to break them down than it does to introduce them. So you may feel, even if your pipes may not be better yet, like you might still have problems at your house, right? Until those needs are taken care of, the bottom needs, the rest of it, the love and belonging, connecting to your friends, connecting to your teacher, connecting to material, any form of connection may be a struggle for you. It's why we talked about impoverished community. It's being at a disadvantage for more reasons than just money, right? It's like you literally don't function as well when you're worried about certain things. If you don't know where your next meal is coming from, you don't really care about balancing an equation. You're like, dude, I gotta eat. Like, this is not what's important right now, right? So that's what this is. I'm just trying to give you guys context for the feelings that you may or may not have. I know me personally. Here, let me stop sharing. I know me personally, and I share this with you guys so you know that it's totally normal to have these feelings. I sat down Sunday, so I didn't get to shower for like a week. Okay. I felt disgusting. Like that was awful. Right. And I finally took a shower on like Saturday or Sunday or whatever it was when they said it was okay to use water again. And I took the shower and my kids were in their room watching a movie in bed, eating snacks that we had cooked in the air fryer because we had power and everything else. And I sat on the couch and I didn't expect it, whatever. I started crying, like not ugly tears, but like it happened. There was big emotions. And I was like, where the heck are these coming from? Right. And then I had to sit and go, you know what? I just sat there literally all week, like this, like tense, like my whole body, my emotions, like holding your breath, waiting for the shoe to drop. And it never dropped, but it just like, oh my God, it didn't happen. Like, but you're sitting there waiting for it to happen. It's like you're at the top of the roller coaster for literally a whole week and you're like, oh my God, oh my God, oh my God. Okay, I didn't even fall. What the heck? Right? Like your body just releases emotion. Okay. So if you during this week, you may be tuning me out because you're like, oh my God, I hate feelings. Or if you're not and you're listening and you're pretending you're totally cool with your friends, but you have like that little feeling in the back of your head that's like, you know, that was really scary. I'm really not okay. Like any range of emotions you feel about what happened last week is valid. Okay. And you need to let yourself have those because that sadness, that crash is a process for healing. If you just pretend you're not sad, you will never actually heal. And to be clear, there is something you need to heal from because the definition of any traumatic experience, I know trauma is a word that gets blown up to mean what like when I was a kid, I thought trauma was really big things like, oh, I wasn't mugged in the street, so I don't have trauma, whatever. But trauma is actually a very nuanced word. It means something happened that was too much, too fast, or too soon, and your body had a hormonal response. Last week was too much. Oh my God, was it too much? It was too much for everybody. Even if it didn't happen, you didn't know if it was going to happen and you were waiting for it to happen. That's too much. It also happened really fast. They're like, oh guys, the power might be out for a day. And then it was like 6 days that we didn't have power. And you're seeing all these things in the news. And they're like, oh, here's a warming shelter. And here's how you keep your house warm, like a homestead person. Like it was crazy, right? And then everybody comes back to work this week. And what was traumatizing to me is they were just like, yep, okay, back to business as usual. I was like, but what about what just happened? Like that was a lot. You were trying to move on too soon, right? Just let it be what it is. So if no adult in your life has sat there and said, hey, you're going to have weird emotions. It might be yesterday. It might be today. It might be in 2 weeks. You might just be moody. You might just not feel like yourself. You might not be able to perform in school like you used to, and you don't know why, but you think you're fine and whatever. All of those things are normal. You're not broken, and it's okay. Have a support system. I know a lot of you guys in here are friends. Friends are a support system. Parents are a support system. I can help you find an appropriate support system. It's not appropriate for me to be a one-on-one support system for you, but I can get you to resources where that is appropriate, if that makes sense. So if you need something, let me know. But yeah, so that's my 5 minutes. The last thought I want to give you guys, because I also had one of my students in my IB class. My IB classes are smaller, so we talk a lot, like, and I get to know them really well. And it's like 9 people, and we're just, it's a really cool environment. And when I was talking to them, one kid said, well, I'm not allowed to be upset because I didn't have my power out for very long. I live next to the fire station, whatever. And the thought that I want to leave you guys with is that, in this part of the conversation, is that saying you shouldn't be sad because other people have it worse is just as illogical as saying, well, I'm not allowed to be happy because other people have it better. When you say it the opposite way, it sounds really stupid. Like, what? I'm not allowed to be happy because other people have more? That's dumb. I can be happy for whatever I want. I'm enjoying my little moment right now, right? But we always tend to say, well, other people have it worse, to avoid our own sadness. Your sadness is valid. Your experience was independent of everybody else's, and it's okay to feel however you feel. So, mushy feelings over, but I wanted to stop and take a breath and tell you guys that it's normal to feel whatever it is in any range of emotion. And if you don't feel like you don't feel anything, that's fine, but someone in here may have needed it. So thank you for being patient and listening. Okay. Does anyone have any questions about that? Anything at all? Yeah. The other thing that someone just said something directly in the chat that made me think of that is that I think adults don't take the time to talk to you guys about it too, because most adults are kind of afraid of teenagers. And I don't know why. I think it's because they know how awful they were as a teenager and like, oh my God, they're probably awful like I was. But like, you guys deserve to be talked to as well. Like, it's very easy to just like go, oh, nope, let's just pretend it never happened and then everything's going to be fine. But that's not teaching you guys how to function in the real world. So that's why I do this. Yeah, and more people should talk about it. I agree. That's what I was saying. In my high school, no one ever talked about it. Like I grew up in Detroit, like of all the places to talk about, hey, weird stuff happens and you might have feelings about it. I feel like Detroit is that place and no one ever did. And I was like, how are you all just fine? I'm not fine. A kid died at school yesterday. How is no one talking about it? I'm not fine. I don't want to be at school today. Like, I don't know. Like, I got really upset about it. So that's why I want to make sure that we have space. But we can go to science stuff now. So shifting gears to science things. Boop, boop. All right. So we're going to kind of review acid base a little bit. I want to show you how many of you actually did the pivot lab. Did a lot of you actually go into it at all? Have we touched it? Like, give me a range. That again, it's not required right now. I just kind of want to know. You can drop in the chat if you did or didn't, just so I can see. Okay, a couple people did it. Briefly looked over it. Okay, so if you guys want me to, yeah, it's okay if you hadn't touched it. It wasn't supposed to be due until the week of snow day. Like, you guys didn't have to touch it. I'm just trying to get an idea. If you did do it and I grade it and you feel like you did really well, I will also take the higher grade between, I will find a way to help that grade benefit you for doing the extra work. But I haven't figured that out exactly in my headspace yet because we're not allowed to do extra credit. So let me figure that out. So I'm pulling it up. So titration. So the reason titrations the reason that titrations exist, okay, is because we don't always know what we have, right? We don't always know the pH. We don't always know the hydrogen ion concentration. We don't always know these things, but we can find them out, right? If you have an unknown acid or if you have a known acid of unknown concentration, right? I might know it's hydrochloric acid, but I don't know how strong it is. You can use something you know to find out something you don't know, okay? So that's the idea behind titrations. Am I sharing my screen? Yeah, okay. So this was the lab. So what we're doing in this picture, okay? So in this beaker, we have hydrochloric acid, HCl. In the burette, which is what's dripping into it, we have sodium hydroxide, okay? So if we don't know how much hydrochloric acid we have. We add NaOH to figure that out. So let me show how that works. Okay. So you have, okay. So to make something acid or base, let's do the quick review. Hold on. Oh, I forgot the wheel. I knew I forgot something. Oh, no one reminded me. This is all your guys' fault. Hold on. Just kidding. It's not your fault. Oh, that's 5th period. That's not going to be helpful. Open 6th period. There you are. Hello. All right. Kai, when we have an acid, what does that mean is happening in solution? Pretend this is a beaker, right? Some of the waters are together, some of them are ionized, 1 times 10 to the negative 14. What would make this an acid or a base?
Acid means that like there's more hydrogen than the hydroxide.
Yep, so this would be, that was weird. This would be an acid because I have more hydroxide or hydrogens than hydroxides, right? Now, if I wanted this to be a base, which one would be winning?
The hydroxide.
Yeah, if I had more OH minuses, now that would be a base, right? So what we're saying is happening in this beaker is we're gonna ignore the Cl minus part. We're gonna ignore the chlorine for now because that's not what we're dealing with. What we're saying is that we have a bunch of H plus in a beaker, right? We don't know how many, but we know they exist. So this is our beaker, okay? In our burette, that's an awful beaker. We're just gonna pretend that didn't happen, move on, okay? In our burette, we're adding something that is OH minus. So when I drop these into the solution, what happens? What happens when I add these hydroxides? Wajiha, what happens when I add the hydroxides?
Oh, sorry. Did you call me? I was.
Yeah.
hopping on something.
So right now I have lots of extra hydrogens, right? And my burette is full of something that has hydroxides. What happens when I add those hydroxides to the hydrogens?
Will the solution become a little bit more basic and neutral? Or
Yeah.
oh, they bond.
Yeah, so, well, yes, all of everything you just said was true, all of it. So good job. OH minus takes away hydrogens out of the solution. So now these start having partners. As I take away hydrogens, when I take away H plus, right, and I pair it up with an OH minus, my hydrogen ion concentration is decreasing and my pH is increasing. I'm getting less acidic, okay? So what we do for a titration is we have something called an indicator inside the solution that will turn a color once it becomes basic or neutral, like 7.6. So when you see the color, it means that every H plus is paired up with an OH minus. It's an ion to ion pairing. So we are slowly adding hydroxide, okay? We are slowly adding hydroxide until all of these hydrogens are now paired up, okay? Pair them all up. Once that happens, our solution changes color. That is what we're about to see. So let's look at what that looks like in real life. I know some of you already watched this, but we're gonna look at it anyway. So that was the indicator that's gonna turn pink, okay? We're adding sodium hydroxide. And do you see how you start seeing flashes of color? The reason that we're mixing that is so that all the ions are equally mixing and bonding as quickly as possible, right? But we are gonna go until our solution turns pink and stays pink. So there, the solution turned clear, so it's still not there yet. This is where it stays pink. Even when it's spinning, it stays pink. So at 42.5 milliliters-ish is when this is considered titrated. The color change occurred, it stayed. So again, tell me what that color change means and happening in the beaker? Bob, what's happening in the beaker right now when it turned pink?
Did the pH change to a number closer to 7?
Not closer to 7, above 7. We're now slightly basic. So that means that if we had hydrochloric acid, we had more H pluses. Once it turns pink, it means every H plus that used to be alone is now coupled up with one of the hydroxides we added. So now none of the hydrogens are free agents. Okay. It turns pink when we have slightly more hydroxide. So we use this as a qualitative, it's a color change, to figure out how much we have. So whenever you see a titration, know that the concentration and volume, or the number of moles of what you added, is equal to the number of moles that what used to exist. So this is like saying, hey, I want to know how many left shoes I have. So I'm going to count all my right shoes. And if I have all those right shoes, that means every right shoe must have a left shoe partner. So that's how many left shoes I had too. That's the analogy here. So if I have something like in my beaker, okay, we're gonna do mole to mole comparisons. Okay, so next up. All right, Maddie, if I have a beaker and it contains 1 mole per liter, or 1 molar of HCl, and I am adding NaOH to it, right? Actually, I shouldn't say what molarity it is. If I have HCl, pretend, ignore the 1 molar. I don't know what the molarity is of this. I did it backwards. But I do know that I added 2 moles of NaOH. How many moles of HCl must have been here? At 2 moles of NaOH, the color changed. How many moles of HCl must I have had in the beginning?
2 moles.
Yes, why?
Because there's 1 hydroxide in NaOH and 1 hydrogen in HCl. So they have to balance each other.
Perfect. What about if I don't know how much H2SO4 I have, right? I don't know the number of moles, but I do know that I added 2 moles of NaOH for the color change. Same problem, different acid. At 2 moles of NaOH, the color changed. Victoria V, what is the number of moles of sulfuric acid that must have been in the beaker?
One mole?
Yes, why is it 1 mole?
Because there's 2 hydrogen to pair up with the 2 hydroxide.
Yep, it takes 2 hydroxides to neutralize every 1 H2SO4, so it's half as much, okay? So that's the idea. This is the hardest concept in acid base. You can even do things like, if I don't know the number of moles of HCl and I add BaOH2, I added 1 mole of BaOH2, okay? How many moles of hydrochloric acid did I have to begin with? Carter. This is when the color changed. Are you there, Carter?
Yeah, I'm just not quite sure.
Okay, so if you look here, we have 2 hydroxides. So every 1 mole we add, we're adding 2 moles of hydroxides. Does that make sense? Because each time this breaks up, you get Ba2 plus, an OH minus, and an OH minus. When this one breaks up, I have an H plus and a Cl. So when I add this, one of these hydroxides is used for each individual acid. So each one of the barium hydroxide takes care of 2 HCl's because you're comparing H's to OH's. Does that make sense? So that means we have twice as much hydrochloric acid. You don't have to necessarily do them like this, but I want you guys to see the hardest part about titration is knowing that it is mole to mole or ion to ion, because we do things in terms of volume, right? Which means we're using a molarity equation. So we have 2 questions. This is actually warm up 8.5 in your key, in your and not in your key, in your Canvas. But I wanted to actually go through 2 problems as examples. Okay. So Sneha, the color changes based on the indicator, like phenolphthalein and et cetera, turn at 7.6. So technically it's slightly more, but it's close enough to get us an approximation we have if we don't have a pH meter. That's the idea. Okay. So, yeah. So let's do this problem. Okay. So this problem says 8.25 milliliters. Again, you will need your reference packet per always. My favorite piece of paper. I know it's been a while since I mentioned it, but it's still my favorite and I still need you to have it out. Okay. This one right here, we're going to use it. I'm going to reload it. Okay. So it says that 8.25 milliliters of a 0.750 molar solution of sulfuric acid was used to titrate 12.17 milliliters of a potassium hydroxide solution. What is the molarity of the base? Show all work, including the neutralization reaction that occurs. Jessica, that was a lot. Tell me what the question is asking us for.
It's asking for the molarity of the base, which is potassium hydroxide.
Yes, so it's asking for the molarity of the base, which we know is potassium hydroxide. So our question is the number of the molarity or the concentration of potassium hydroxide. Okay. That's what it was asking us for. All right. So this is our question. What else does it want us to show?
It wants the neutralization reaction between sulfuric acid and potassium hydroxide.
Yeah, so neutralization, remember, is acid plus base gives me water plus salt. So that's what it's asking us for. Okay. So let's build that neutralization reaction before we start looking at the math. Victoria C, are you here today? No? Okay, Faisal, are you here today? Yes, I see you.
Yes, I'm here.
Awesome. How do I start building the neutralization reaction? What's the first compound I got to figure out?
Okay, so the first thing is the acid. So you're trying to figure out sulfuric acid.
Yes. So how do I figure that out?
That's just, okay, so it says acid, so it's going to have an H.
Yes, we know it's going to have H+. What else
and
is
then in the reference packet, sulfuric is SO4.
Yep.
I think
So where he's looking, guys, if you want to see, I will pull the reference packet up. There's the acid and base naming chart. So if you go here, just as a reminder, because it's been a minute, right? We have sulfuric acid. So that is using this rule, sulfuric acid. So we know that it's a sulfate ion, okay? And then the number of H pluses is the charge. If I do sulfate, I see that it is SO4 2 minus. Okay, so that's where he got that from. Okay, how many H's do I need then?
2 H's.
So that's going to be H2SO4. And what's the phase?
It's
solid, liquid, gas, aqueous.
I think it's going to be okay. SO4. It's going to be aqueous.
Yes, acids and bases will be aqueous in most cases, right?
Yep.
All right. So next one, I'll ask someone else for the next compound. What's the next one I have to build? Sangeet, what's the next one I got to build?
Potassium hydroxide.
Potassium hydroxide. So how do I build that? Potassium is which ion?
It's K plus.
And what's hydroxide?
OH minus.
So how does that compound look?
It's just KOH.
Yes, because it's a one-to-one relationship. And what's the phase?
Aqueous.
Awesome. All right, so now we need to form the products. So neutralization means we're going to be doing a special double replacement. Izzy, help me out. What do I do?
So since it's a double replacement, you'd have like KSO4, but you have to work out the charges and stuff. So it'd be like K2SO4.
Yep, you'd have K plus and SO42 minus. So I need two K pluses to balance the one SO42 minus. So that gives me K2 SO4. Ooh, come back. K2 SO4. All right, awesome. And what phase is that? Not one of the ones we know offhand, so we have to look in the reference packet. Okay, so we have rules for sulfates, right? All salts of sulfate are aqueous unless it's one of these, which it is not. So we know it is aqueous. Okay. All right, what is the other product for neutralization? What's the other product for neutralization? We use the K in the SO4, right? So this is the only thing that's left. What is our other thing? Are you there? I know you were having internet issues earlier. No? Okay. SD, what's our other product? Acid and base yield salt and what thing?
Water.
Yep, and what phase is water?
Aqueous?
Aqueous is when something is dissolved in water. Water itself is a compound. So which one? It is that fluid form, but it's not aqueous. What is it?
Liquid.
Yep, it'll be a liquid. All right. Now we have a good job. Now we have a chemical equation. Trisha, what do we have to do to this equation to make sure it is good to go?
Balance it.
All right, so help me balance it. Now remember, I'm going to give you the hint because it's been a bit, is that you should view this as H and OH when you balance it. So the H2 kind of throws people off, but if you balance it as H's and OH's, it balances much easier. So let's go ahead and balance it. Help me out.
I think you need 2 KOH.
Yes, why do we need 2 KOH?
To balance it on the other side, to balance the OH on the other side.
Yeah, so OH, well, this is a single OH and a single H, right? But here we have a K here and a K2 here. So we know we need the 2, right? This gives us 2 hydroxides. How many hydroxides do I have in the water?
1.
So what do I need to put here?
2.
So now I have 2 H's and 2 OH's, which balances the H2 part, right? If I do the math on this, 2 H's plus 2 H's is 4 H's, and this gives me 4 H's. S is single, O4 is there, plus the other 2 O's, plus the other 2 O's, so that's all good. Then we have potassium is 2, and we already counted for those hydrogens. So that's why I said balancing by the polyatomic ion is much easier. We don't have to write the 1s in front. We can, but we don't have to. So that's why I omitted the 1s. Okay, so that's a good review for that. Now, the next thing is stoichiometry, right? We're asking for a compound, but remember, when I see molarity, when I see a capital M, what do I have to remember that means? Sonali. What does that capital M actually mean? What should you think?
Is it moles per milliliter or liter?
Yes, it's moles per liter. So when you see what is the molarity of the base, the end of our railroad tracks should have moles on the top and liters on the bottom. If we do not, we did not solve it, right? And we're looking for moles per liter of KOH. So KOH is what we're ending with. So Jonavi, what does that mean we have to start with, right? We have 2 sets of numbers. We have 12.17 milliliters of potassium hydroxide. We also have two numbers related to sulfuric acid. Which compound are we starting stoichiometry with? Which compound? Potassium hydroxide or sulfuric acid?
So it's asking for the base, so you would have to use 8.25 milliliters?
Yes, it's asking for the base, so the base has to be the end, right? This has to be the third step. So if KOH is at the end, we have to start with sulfuric acid in the beginning. And then we always start with the known that's alone, which is milliliters. So we are starting our railroad track with 8.25 milliliters of H2SO4. Okay, that is what we are starting with. Perfect. Now, what is step one of stoichiometry? Sneha, what's step one of stoichiometry?
Convert to moles.
Yes, we need to, step one, convert to moles. We have milliliters, right? So we have a couple givens. We already used this given. So what's our only given left about sulfuric acid?
That we have 0.750.
750 moles per liter, right? So here's the problem. What's in my molarity versus what's in my given? Do those match?
No.
So what do I have to do first?
Do you have to convert it to, because there's milliliters and liters, which doesn't match.
So milliliters is on the top, so it needs to be on the bottom for the next one. The milliliters cancel. I now have liters of H2SO4. Perfect. So now that I have liters of H2SO4, what can I do now that I have liters? Shanmati, what can I do now? What piece of data can I use?
The 0.75 molar.
Yes. So which one? What does the 0.750 moles go on the top, or does the liters go on the top?
The moles go on the top.
Yes. So we have 0.750 moles of H2SO4 for every 1 liter of H2SO4. So now we can see, if we do all of our canceling, that milliliters canceled, liters canceled, and I converted to moles. That was my step one. So when I tell you guys stoichiometry is always the same, this is converting to moles. That's all I did. So that's the exact same as we've done. All right. Next up, Eden, how do I, so we converted to moles. What's our next step?
The mole to mole ratio.
Yes, step two is mole ratio. So how do I do that?
You'll put 1 mole of H2SO4 at the bottom, and then 2 moles of KOH at the top.
Yep, for every 2 moles of KOH. All right. So remember we said our question was asking us for moles over liters, right? So moles of KOH has to be on the top and liters of KOH has to be on the bottom. Right now we have moles of KOH. That's half our problem. So what do we need to put on the bottom here? Corey, what do I need to put on the bottom?
Like to the right of that? Oh. Hold on.
We need moles over volume. We have moles on the top. What's the number we haven't used yet?
Oh, 12.17 milliliters. So you have to convert it to liters.
Yep, so if we do the 12.17 milliliters and do the conversion of 10 to the 3 milliliters over every 1 liter, you could have put this into your railroad track. I just ran out of space. So that would have given us 0.01217 milliliters of KOH for over 1, okay? So now I have moles of KOH over liters of KOH. That's what I asked for. When you plug this in, you should get a number. I want everybody to plug into the calculator and then put in the chat the number that you get, Okay, put into the chat the number that you get, because calculators are stupid and we need to know that we know how to use calculators. Yes. So when you plug this in, you should get like 1.016 or 12, like anything that rounds to 1 point or 0.0. Wait, what is it? 1.02, I think is what it is. Let me look. Yeah, 1.02 molar. So for this, you would get 1.02 molar KOH. Okay. We're going to do another one. Okay. So if you're off by an order of 10, it means that you probably forgot this. A lot of you are 3 decimal places off, or you didn't do. So if it's an order of 10, it has something to do with where you put your decimal places. So let me show this. Where are we confused? Hold on. I'm getting questions in the chat. We're going to do another one. KOH, the 0.01. So we're looking for molarity, which is moles, which we have here, over liters, which we have here. Remember, moles divided by liters. So if we have moles divided by liters, this means this railroad track will give us the answer. Does that make more sense? This is what you get after you plug into the calculator. So when you plug into the calculator, hold on. You should be getting, stop that. Stop that. You're useful sometimes, but not right now. Hold on. Boop. Just to give you guys clear. When you put this in the calculator, you should be doing open 8.25, close, open 1/1000 or 10 to the 3, however you want to type it in, close, open 0.750 over 1, close, open 2/1, close, open 1/0.012717, close. When you do that, that will equal 1.02-ish approximately molar KOH. The blue one was to get this number. So that's where I said I ran out of space, which is not ideal. If I would have done this without running out of space, I would have had 8.25 milliliters of H2SO4, okay? And then I would have put the 1 liter over 10 to the 3 milliliters, the 0.750 moles of H2SO4 over 1 liter of H2SO4. Then we would have had the 2 moles of KOH for every 1 mole H2SO4. And then we would have kept going. And I would have said, okay, put the 12.17 milliliters on the bottom, and I need to cancel that out. So my next track would have been the 10 to the 3 milliliters over every 1 liter. So this is the same thing. And if I would have had the space, that's what I would have done, because you know that molarity is moles over volume, and then we just had to make our volume the right unit. So I'm sorry that I had to like divert down to the bottom, but if you do this, everything cancels except for moles of KOH over liters of KOH, which is what we wanted. And that will give you 1.02 molar-ish. Does that make more sense? I'm so sorry. each mole of KOH, we know what it's worth because of this. This is the moles of KOH. This is the volume. Okay, good. All right, another one. So here's what I want you guys to do. I want you to try to start this. I'm going to give you guys about a minute or two head start. Okay. So when I start calling on you, you should already be having identified the important information and going through and starting to rate your reaction. So I want you to get through at least the reaction. Try to do that in like the next minute or so. I'm going to mute myself for just a second. So my typing doesn't like annoy you, and I'm going to start calling on people, and we're almost at the end of our list. So the list may start over. So we'll call on everyone and try to go through this one a little quicker, but I want to give you the chance to try to do it. Okay. Because again, this is for your test on Thursday, and I want to make sure you have a good example. Okay. Have you guys had enough time to kind of work through and do your reaction, or do you need another minute or two? It's okay if you need a minute. I don't want to rush you. Okay, I'll give you another. Okay, guys. All right, I will start using the wheel to start working through this a little bit. So if you were kind of in something, kind of pull your brain out of it. All right, Renee, first up, what did you identify as the question here?
It's asking for the molarity of the nitric acid.
Molarity of the nitric acid. Awesome. They're very straightforward. What else do I have to make sure I do?
You have to show the neutralization reaction.
Right, and that's what we use in the stoichiometry for step 2 of mole-to-mole comparison. Awesome. Next up, Akshar, how did you start trying to build your neutralization reaction? What were the compounds you identified?
Nitric acid and calcium hydroxide on the reactant side.
Yeah, so nitric acid and calcium hydroxide are the acid in the base, because the acid means the H is in the front, hydroxide is OH in the back. So that's going to be our reactants. Did you make a formula for either of those?
Yeah.
Okay, what did you get?
HNO3 and CaOH2.
Yes, because nitric acid means we're using the blank-ic acid rule, which means that nitric is actually nitrate, which is NO3 minus, which means we need a single H plus in the beginning. Awesome. All right, next up, what did you put for calcium hydroxide, Charles?
CHO.
So you have
Or
C.
CA, sorry.
Yeah, you're good.
My bad.
You have Ca. What charge is Ca? What charge is calcium? Using your reference packet. You can go look on the periodic table. The second periodic table.
Would it be C2?
Yeah, so Ca is 2 plus.
Yeah.
OH is a single minus. So what?
Oh, okay. So OH2.
Yeah, there we go. We
In
need
parentheses.
OHs, and that's also aqueous because it's a base. Awesome. When I see the word neutralization, what do I know my two products are? Wait, I already called on you. What's it doing? Maheen, what are my two products in neutralization?
Water and salt.
Water and salt. So water would be what? How do I write water?
HOH or H2O.
Yes. Yeah, well, yes. So we see when we recombine them in the formula, it's the H and the OH coming together. That actually makes it easier to balance. We're just used to seeing H2O as the common chemical formula, but that's the same thing. I love that you wrote it that way, and I actually think it's easier to balance that way. So we're gonna keep it. All right. And then what is the salt? Jimin, what is the salt here? How do I tell?
The salt here.
Yeah, we used H and we used OH. So what are the two parts of the compound left over?
Oh, calcium and then NO3.
Yes, calcium is 2 plus. We already looked that up. NO3 is 1 minus. So what is the proportions of those? How many of each one do I need?
You need 1 calcium and 2.
Yep. 2 nitrates. Yeah, I got you. 2 nitrates. So then we need to figure out if this is solid or aqueous. In our solubility chart, in our handy dandy reference packet, we see that all nitrates are soluble with no exception. So this has to be aqueous. All right. Awesome sauce. So now we have our reaction. How did you balance it, Magana?
I had 2 of HNO3 and 2 of water.
Yep. So if I have 2 HNO3s, it's because I have 2 nitrates here. So I needed 2 nitrates here, right? And then that gave me 2 H's. So I needed to have 2 H's here. I already have 2 OHs on this side. So that gives me 2 OHs on this side in the single A. So we end up with 2, 1, 2, 1. You do not have to write the number 1, but I am writing it for posterity's sake so people don't think that I forgot to do it. All right. So now Dia, we have to set up our railroad tracks, right? So we are going to set up our math here. So what's step 1 of stoichiometry?
Wouldn't we have to convert it to liters?
Yeah, absolutely. Because so our goal here, so let me backtrack for a second. So we're starting with the calcium hydroxides, right? Because our question is for nitric acid. So if our question is for nitric acid, this has to be the end of our stoichiometry because that's what we're trying to end with, right? That's our question. So that means we have to start with these. And the jump that you made, because you already went like 3 steps ahead, which is so fabulous, is that we know that we were given milliliters, and we need to convert this to moles, right? So this is the milliliters of CaOH2. And we know we need to get it to moles, right? So we convert to liters first because the capital M is the same as moles per liter, and our milliliters and our liter did not match, okay? So to get to moles, we have to have liters, which is why we're converting. On the formula sheet, it'll tell you there's 1,000 milliliters for every liter. So Dia, which one goes on the bottom? Which one goes on the top?
The 1,000 milliliters will go on the bottom and then 1 liter on the top.
Yes. And this is for CaOH2, right? So now we have milliliters cancel. Milliliters cancel. We're left with liters. Awesome. Adhesh, how do I use the 0.0250 molar to get to moles now?
You would put it over 1 liter.
Yes. So remember that capital M means it's 0.0250 moles for every 1 liter of CaOH2. I'm putting it up top so I don't run a space again, guys. So I know it's not as pretty as it normally is, but I needed space. So it's not me, or no, it's not you, it's me. I need space. Huh, jokes, maybe, no, okay. So mole CaOH2. So that was step 1, convert to moles. That's what this was. We used our data to get moles. Samir, what's step 2 of stoichiometry?
Molar conversion, like the ratio. Yeah.
Yeah, you had it. Mole conversion is the same thing as mole ratio. We need to take moles of what we know to moles of what we don't know. So how do I do that here?
So what you do know is what you got is calcium hydroxide, and you're trying to go to water.
So what is it asking us about?
Oh, nitric acid. My bad. So
going from this
to that, yeah. So for every 1 mole of that, you get 2 moles of nitric acid, which is HNO3.
Perfect. All right. So pause. Our question asked us for, because the 3rd step is to convert to desired, right? So convert to question. Okay. And right now we desire molarity, which is moles over liters for HNO3. So Audrey, we have moles of HNO3. How do we get the liters part?
Do you have to? I'm not sure.
Okay, so right now we have this locked in. Our answer needed moles of HNO3 on the top, so we don't have to touch moles anymore. So we're viewing this as a visual break. Instead of dealing with the moles of HNO3, I now need the liters of HNO3. What did they tell me about HNO3? How many, what?
Sorry.
No, go ahead.
That there's 10.30 milliliters.
Yes, so we know we have 10.30 milliliters of HNO3. We're putting volume on the bottom because molarity is equal to moles over volume. So we put our volume on the bottom and then convert it to what we need it to be. We're taking the moles and dividing by milliliters, but milliliters isn't what we needed. We needed liters. So what do I do now? Darshan, what do I do now?
Then don't you say you put milliliters on the top and then liters on the bottom. So it's 10 cubed or 1,000 milliliters for 1 liter.
Yep. So 1,000 milliliters for every 1 liter. So now I have liters of HNO3 and moles of HNO3. Moles are on the top, liters on the bottom. Moles per liter means molarity. This means I have it set up correctly. Now I want everyone to put this in the calculator and tell me what they got. Did I put oh, I did. I'm so sorry. I just saw you guys did that. I don't know why I said that. Water would be liquid. I just saw that in the chat. Yes, I don't know why I put aqueous. Probably because I was thinking about this one and I wrote this one because I work ahead. Yep. So everyone try to put that in the calculator, see what you get. Yes, Saya, or Sia G. Yes, that is correct, but you need the correct number of sig figs. So your sig figs are wrong. Your value is correct.
Okay, so I know how to get this far. I just don't know how to plug it in the calculator, which is like I think the most embarrassing part, but
it's not embarrassing. Calculators are stupid, right? So it's actually harder to know how to set up all that. So if you're already there, that's the harder part of the battle. So let me do this. Okay. So if I have all of this, stop that. Don't do that. Okay. So now that I have this, I am acting like these are parentheses and I plug it in my calculator like I see it. Okay. So when I do plug it in my calculator, yes, I see all of you are getting the correct value, but none of you have had the correct sig figs yet. No one's had the correct sig figs yet. All right. So I would type open 25.16 close, open 1/1000 close, open 0.0250 over 1 close, open 2/1 close, open 1/10.30 close, open 1000 over 1 close. And that is what we're putting in the calculator. And when you do, yes, Sangeet, you're the first one with correct sig figs. Good for you, girl. Okay.
okay, I did it. Well, I'm so smart. Okay, thanks.
Yes. So you should get 0.1221 something, 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 something molar. But in our problem, this number right here is one of our givens. And these are not sig figs. It only has 3 sig figs, guys. So you have to round this to the 3rd sig fig. Count 1, 2, 3, round back. My answer should be 0.122 molar HNO3. Okay. All right. So remember, all QCs are due before your test Thursday, right? You have extra time. The pivot lab is no longer graded. All right. The practice test is what I want you to do before the test to make sure that you are ready. Okay. So took out an entire lab. Everything else is the same because you would have done the practice test anyway, right? So focus on that stuff. And then after that, the test is going to be like the last grade in the grade book. If you retake the test after grades come out, we can do a grade change request. So I don't want you to panic about that. We already know that's coming, but we can't like not put the test in there. So we have to. So, and this is a team thing. So make sure you have all your QCs done. You should just have 8.5 left before your test, which is Thursday. Make sure that you have your practice test, that you're working on that the next 2 days. And remember to give yourself the space to like understand you're not going to feel necessarily like you're doing as well as normal because you've had a lot of stuff going on you're processing, and that's okay too. All right. I am working hard to get grades updated. I did not have internet at all. Like Frontier went completely out. So like I couldn't do anything. I didn't even have I had to keep the power on my phone conserved. So like I didn't get to do anything last week. I was hoping I could catch up, but that didn't happen. So I am working hard to catch up on the grades with you guys. Okay. All right. That's all. You guys are free to go. Have a good day, guys.
Thanks, Miss Longley. Have a good day.
Bye.
Miss Longley,
Thank you.
can we go over to 8.4?
Avon, yes. Let me see what everyone else needs before I start going for specific things. All right. Why is everyone else hanging out?
So on the pre-test, there were questions where you couldn't see the pictures, which is why I got them wrong. So
Okay,
I just wanted to tell you.
Oh yeah, I'll go look and I'll no grade those questions for everybody. Thank you for letting me know.
Okay, thank you. Have a great day.
You too. All right, anybody else? No, Celine, you want 8.4? Eden, do you need help with something?
I'm doing my retake for, I think, the Unit 7 test.
Did
Like
you need to
ago.
retake it, or did you already retake it?
I already scheduled it, but that was from like 2 weeks ago.
Yeah, no, you have time. I'm gonna give everyone till Friday to get it done. And I already told the testing center, so you're fine.
All right, thank you.
No problem.